Alrighty friends, welcome back. We have talked about a lot so far. We talked about the mechanical ability of the heart, which we assess by a pulse, seeing how our heart is pumping blood. We talked about the electrical pathways of the heart, the SA node, AV node, bundle of His, Purkinje fibers, and how it just follows that track. And we talked about what made it fire, which is the sodium-potassium pump. And now we're going to talk about how we actually get a waveform on our EKG paper, because we know that our electrodes are measuring those electrical impulses, okay? So here, I didn't have all the correct colors. However, we'll just kind of talk about it. So when we're placing the EKG wires on a patient, so an important thing that we talked about for my EKG course is that the electrodes themselves are the stickers, and these are the EKG wires. They're very, very picky about what is what. So each of these has a place. So I'm just using this as an example for the 4-lead. Like, we know white goes on the right, and then it's clouds over grass or ground, clouds over ground, clouds over grass, whatever, and then smoke over fire. In the US, we have standardized colors for that. So this will be the white one, the green one, the black one, the red one, okay? Clouds over grass, smoke over fire. White starts on the right. That'll help save you at 2 a.m. when you're really trying to put it on your patient. Now, it is important where we place these and that they're placed on the proper limbs. And the reason being, it is each of these wires is stronger or a little bit less strong than the others. So like with the cardiac cells, how none of them were actually truly negative, none of these are truly negative either. However, some of them have stronger pulls than the other, which helps us actually create those angles or viewpoints on the 12-lead EKG when we print them out. So that being said, this one, the white one, is often portrayed as being negative. It's not truly negative, it's just the weakest of them. It is a positive, but it is negative compared to our other two on this side. So this is our least positive, or our negative, white on the right. Our red down here is going to be our most positive pull, okay? And then this one's somewhere in the middle. And then our grass, or our ground, is actually our ground wire, which helps complete the circuit. It doesn't have a true a pull to it. It is just kind of what helps us complete that circuit, okay? So that being said, negative towards the positive, if this is our heart, and we already know that this is going to be the patient's right side, this is going to be the patient's left side, atria, ventricles, right? We're already pros at that. We know that the SA node is up here, and it fires in this direction towards our positive pull. So it starts from the negative, goes towards the positive. So when our electric stimuli fires off up here and goes this way, it creates a positive inflection, which is going to be our P wave. We will go over all of the parts of the P, Q, R, S, T, and sometimes U, but it's just important to know that as it goes from the negative towards the positive, it creates that initial P wave, okay? And we will get into that more. I'm going to show you videos that it's not just me talking about it, but somebody that can give you a better visual. And in real time. I can't really draw it out for you in real time. But hopefully this video will help. 1 second. Okay. And again, we will get into the PQRST, but it helps to kind of see the heart pumping and the electrical system going off while seeing the PQRST go off in real time.
Can be recorded in the form of electrocardiogram, ECG, or EKG. An ECG is a composite recording of all the action potentials produced by the nodes and the cells of the myocardium. Each wave or segment of the ECG corresponds to a certain event of the cardiac electrical cycle. When the atria are full of blood, the SA node fires. Electrical signals spread throughout the atria and cause them to depolarize. This is represented by the P wave on the ECG. Atrial contraction, or
So we'll pause right there real quick. Just so that we can kind of start a visual. So this is the first initial line that you see on an EKG right here. That's called the isoelectric line, which is kind of used for your resting state, that polarized state before anything goes off. That is your baseline before the electrical activity, because we have to measure it, and we'll go over that. It kind of prints out on this graph paper. It starts on the isoelectric line, which means like nothing's happening, and then fire, and we have a P wave, okay? And because it's going towards our positive, that creates that positive inflection, which is our P wave, okay? So isoelectric line, and then the SA node fires, which causes the P wave. That's where we're at so far.
Starts about 100 milliseconds after the P wave begins. The PQ segment represents the time the signals travel from the SA node to the AV node.
Okay, so we've traveled from the SA node to the AV node. During that amount of time, there's this slight break before it hits all the bottom parts of the heart, which is gonna which will represent that pumping ability, right? So we'll get there. We're just breaking it down slowly so that it's not too fast, okay?
QRS complex marks the firing of the AV node and represents ventricular depolarization. Q wave corresponds to depolarization of the interventricular septum. R wave is produced by depolarization of the main mass of the ventricles.
Okay, so really quick, an important thing to note here. Okay, so this was our atria going off, and then that little bit of time that it takes to get to second base over there, and then the QRS complex is really going to be when it's going through your ventricles, because your ventricles are bigger and stronger and they're pumping a lot of things out. So both our atria and our ventricles have to polarize and depolarize and repolarize, right? So the P wave is the atria going off, but then it also has to reset. Because the QRS is so much bigger and stronger, the reset actually hides in here, okay? So if we didn't have like a bottom part of the heart at all, we would see a wave and then that and then the re-wave. But because this is so much bigger and stronger and we really see in 2D through the EKGs, all that we see next is the ventricles going off because of how much bigger and stronger they are. Okay, so secretly the atria are repolarizing in the QRS complex, but we don't really see that. So then we just start to see the ventricles start to fire off. And then the T wave, which he'll go over, is that repolarization of the ventricles. So this is happening simultaneously as this is happening. So atria goes off, resets, ventricles goes off, resets, okay?
S wave represents the last phase of ventricular depolarization at the base of the heart. Atrial repolarization also occurs during this time, but the signal is obscured by the large QRS complex.
That's what I just said.
The ST segment reflects the plateau in the myocardial action potential.
So our pump just happened, that big squeeze in the ventricles just happened. So now everything is kind of going to return to a resting state, but it also has that kind of pause after that initial squeeze. Like if you do a rep at a gym and you start up, like you do your curl and then you pause up here before you start to reset and relax. That's kind of what's happening in this isoelectric line right here. It's just kind of, okay, you just did all of that work, or sorry, this one right here. You just did all of that work, that big squeeze, so now you're just gonna kind of rest for just a second before repolarizing.
Ventricles contract and pump blood. The T wave represents ventricular repolarization immediately before a ventricular relaxation or ventricular diastole. The cycle repeats itself with every heartbeat.
Okay, so hopefully that made some sense. Watch the video over and over. So the atria goes off, atria repolarizes, and then at the same time ventricles go off, ventricles repolarize, okay? But we will go over all of these parts and what they mean. We're going to do a part 2, but this is just kind of that initial icebreaker for what causes and creates these waves that we see, the PEQRS.